So good morning and welcome everyone. My name is Jess Larson and I am meshIQ's events manager. We really appreciate you taking the time to join in today. Throughout the year, we host TechTalk webinars on different middleware technology topics. And in case you missed any, we have them recorded on demand as well on our website. So today's topic is defeating the challenges of using Azure Service Bus and legacy messaging. Feel free to send any questions you have throughout the presentation in the Q&A box for the Q&A portion at the end of the webinar. Before we start, I would like to introduce our speaker today. So Albert Mavashev is meshIQ's CTO, currently living in New York. As meshIQ CTO, Albert turns ideas into real-world solutions. His work specialties are application performance, performance measurement and practices, streaming analytics at scale, clustered computing, Big+Fast Data, transaction analytics, complex event processing, middleware, IT service management, ops, and DevOps. I will now pass it over on to Albert.
Thank you, Jessica, for the intro. And hello, everybody. And today's topic, I'm going to be discussing Azure ESB or Azure SB, and specifically when it comes down to challenges of migrating workloads to the cloud-based messaging platform. And this is going to be especially relevant for folks that have already legacy or existing messaging infrastructure, and you're adopting or possibly already have adopted Azure Cloud and looking into Azure SB as a viable messaging alternative, or potentially even just moving some workloads to this platform. So as part of the agenda, we're going to discuss a few things. One is take a look at the Azure SB and some of its capabilities, as well as what some of the customers that we deal with, what they use it actually for. We're also going to look at cloud migration and integration, and that is more around, well, what are some of the things that you have to consider, and some of the patterns of cloud migration and integration. We're also going to discuss challenges associated with moving workloads to Azure SB, whether that's some new workloads or potentially existing workloads. And we're going to deep dive into the observability and monitoring. That's one of my areas of competence, is looking at monitoring and observability. And we're going to look at some of the best practices and compare siloed approaches versus I call it a cross-platform observability. And then we're going to have a Q&A session as well. So before we dive into the integration challenges and some of the migration challenges, I want to take some time to overview Azure SB as a cloud messaging platform and look at some of its capabilities. So especially if you looked at other messaging platforms, there are things like queues and topics, and other messaging platforms have, especially like JMS and Kafka, have different artifacts and different constructs for messaging, moving messages around. So Azure SB is not different in this respect, in that you have senders and you have receivers, and then applications can send messages from sender receiver, and kind of decouples applications from one another. Each of the sender receiver can be in different language environments. They could be in cloud or even on-prem. And Azure SB provides support for queues, topics, as well as transactions. And that's very important, because if you look at the main use case of Azure SB, obviously it could be used for many different use cases, but one of the main use cases is high-value messaging. And what that means is, if you want to safely move high-value transactions such as order processing, or financial transactions such as payments, Azure SB fits that bill very well, because it allows you to do this in a transactional manner, which means you can send a bunch of messages that actually provide commitment control. It also provides support for queues and topics, and also because it's integrated with Azure Cloud infrastructure, It also you can leverage all of its Azure cloud capabilities, including things like auto scaling. A couple of things to note about Azure SB is that it provides a wide variety of language bindings such as Java, C++, PHP, Ruby, Go, and other C#, Python. One of the main areas, especially since a lot of enterprises make use of Java applications and specifically JMS interface, it's specifically designed in such a way where you can move or port your Java JMS applications directly into Azure SB with minimal changes. And it also supports a variety of different compliance and protocols and standards. One of notable is an AMQP. So it's a very versatile and very functional platform. And if you deploy application already in Azure, that becomes obviously a very viable choice and a natural choice as for messaging and moving messages, especially for high value messaging. So now that we kind of looked at the Azure SB, and it's obviously a good, I would say, alternative to things like IBM MQ and some of these other platforms or GMS implementations such as ActiveMQ and RabbitMQ. So if we look at specifically cloud migration, and especially if you're an organization that is, either have adopted or running in Azure, and you planning to deploy workloads in that environment, already have, there's a couple of ways to kind of look at this. So if you have an existing footprint, let's just say you have some on-premise applications, and now you're layering Azure environment on top of it with an Azure SB, you can connect these things together, in a sense, have a combined environment where your on-prem is in fact almost seamlessly interconnected with your Azure SB environment. Now, in this case, you can look at a couple of patterns here. One is where you're moving workloads across. And in this case, you're saying, well, we're going to maybe deprecate some of these existing messaging platforms and move over to Azure SB. Now, it doesn't usually happen overnight. So what that means is you still have an on-prem footprint, and you just moving some of these workloads, certain percentages of them over a period of time until it's completely migrated. So that's one approach, is you're just migrating workloads over. The other is more of what we see is more of augmenting, is where the on-prem footprint kind of stays the same in a sense, but then you also augmenting your existing footprint with workloads that are completely done in the Azure SB environment. So you now have a combined, I would call it a hybrid environment. It's an on-prem environment, but also interconnected with your Azure environment. And that could typically be done via brokers and gateways where the traffic can move from an Azure SB environment over to on-prem, back and forth. So that's an I would call it an augmentation. The other is completely kind of siloed, where you have an on-prem, but there's no real communication between the two. And then you have some new capacity via a new set of applications. So let's say you're rolling out some mobile or cloud apps, and they're not really interconnected. That's a not very common pattern that we see, simply because data, it may not all the data is actually available in Azure SB, and it's available on-prem. So you still have to create some bridges and gateways to be able to access data in the cloud environment. And part of this consideration is when you look at the integration of these two cloud and on-prem environments, is obviously when you're moving applications, you may also want to consider things like code changes, because as you deploy these on-prem applications over to the cloud, not only you have to potentially port them to use to Azure SB, but you also need to take into consideration all the cloud services. So, and making use of this cloud services, so that may require some code changes. So the cloud migration integration, mostly what we see is you have an on-prem footprint and you have a cloud footprint, and then it's interconnected via a set of bridges and brokers and applications that make this integration possible. And then we'll discuss that in terms of what that means from the observability perspective. So what are some of the challenges that one may run into? Well, there's actually a bunch of them, and we touched on them early on. But one is obviously the integration complexity. So now that you've layered your Azure SB and the cloud environment, you have to think about how these two environments, your on-prem environment and your cloud environments, are going to kind of coexist. So that means integration, more integration. The other important thing to consider is where the data is, and whether do you need to migrate some of the data from your on-prem to cloud, and if so, what data should it be? And then that ties into, in fact, data and where the data is ties into things that you, or I would say the how it affects your latency performance as well as security and compliance, because it all depends on where the data is, what kind of data, where does it reside, and how is it accessed. So all of that can impact your performance, but also has other implications such as in security and compliance. So consider data and where the data is and how it needs to be accessed from your cloud environment. Monitoring is observability obviously is going to become another, I would say, issue or a challenge, because not only you have to, and we're going to dive into that in a little more detail, not only you have to worry about or observe the on-premise environment, but now you have a completely different environment in Azure. And the question is, how do you reconcile the two? So that's something obviously to pay attention to. And the other two things are cost management and skill gaps. And obviously on the cost, since now it's a pay per use model, you have to obviously pay attention to volumes and how much data you move and potentially throughput and bandwidth. So that's something to consider. And then skills, because you may have to reskill your folks or potentially acquire new skills to be able to deal with this completely new environment, because Azure is SB and the whole Azure cloud environment is a completely different environment versus what you may already have. So this is some of the things that that you may want to consider in terms of the challenges that you'd probably come across as you moving or augmenting your existing on-premise environment. We're going to dive into specific, because we can't cover all of those challenges. But what I'm going to dive more specifically is into the observability and some of the monitoring challenges that you may run into. So let's take a look at the specifically on observability and on-premise versus cloud. So if you have an on-prem environment, you'll probably have a set of tools for observability and managing that specific environment. So let's just take this as an example. Let's say there's Kafka, there's MQ, and there's other messaging platforms. So obviously you're going to need to manage and monitor these environments. So now let's assume you now augment this environment into this hybrid where you also now have this Azure cloud environment and Azure SB. So in this case, now there's a new set of tools that you will need, or at least what we see customers have is they have these on-prem stack, and now they have the whole cloud stack. Now, usually it's addressed the organization where there's an organization or a set of people that deal with the cloud environment versus on-prem, and a lot of times it's not interconnected well. But in this case, the cloud team uses cloud tools and on-prem team uses on-premise tools. And then we'll see how that actually affects the whole environment. But when you have this kind of, I would call it siloed or disjoint setup, it's obviously multiple tools, which means multiple skill sets required, multiple people required to manage this environment. It's very difficult to get an end-to-end picture of what's going on. So people who manage on-prem look at a bunch of tools to see what's happening in their MQ or Kafka environment, versus if the issue is potentially in the cloud, then somebody's going to have to look at the Azure SB. And then the question is, where should even somebody be looking at? And that's another topic altogether, which is, how do you even track your message flows? That becomes a challenge here, because data is constantly moving from one side to another, right? So you've got data moving from on-prem to cloud or cloud to on-prem. And when you run into questions of latency or timeouts or performance degradations, it becomes very difficult to track down where the problem is. And that obviously results in increase in MTTR, mean time to repair, mean time to recovery, because even just figuring out what is broken where or where the latency is becomes a challenge, a very significant challenge. The other thing, obviously, one must consider is how do you even deploy applications in this environment? Some will have to be in the cloud, some will have to be on-prem, and then how do you deploy artifacts? And today, most of the applications are now deployed via CI/CD pipelines, which means now you have to consider how does this environment and how do you tie this whole environment into a CI/CD pipelines, which means when you roll out your applications, the changes have to be deployed both on-prem and cloud. And how do you coordinate those two is something that I would say somebody's going to have to consider. And the more moving parts you have on the observability and the management stack, the more complexity and the higher the cost. And usually what we see is a dramatic increase in mean time to repair because of, again, this disjoint, I would say, siloed approach. Tracking messages, again, I would say something that becomes very important because gigabytes, petabytes of data moves across. How do you know where the bottlenecks are? So that's, I would say, is a challenging problem. So oftentimes what we see is, people ask, where's my message? And because Azure SB is really designed for high value transactions, a lot of times it will be, well, where's my payment? Where's my order? Where's my invoice? And not be able to answer these types of questions creates a significant risk for the business. Now, if we want to look at what actually we think it should look like, and obviously the ideal is to get into a single cross-platform, one platform for observability across the whole stack. Now here I augmented it with other cloud services because oftentimes Azure SB and other on-prem services are also going to be used in conjunction with some of these others. It could be Google Cloud, it could be AWS. And in fact, oftentimes we see multiple cloud providers being used in the same environment. So in this situation, it gets even more complex, but the idea is to be able to go from this kind of disjoint siloed into a cross-platform single observability model. There are a couple of things to consider here. One is a lot of times monitoring and observability, they focus on metrics. The metrics like volumes, latency, and things like that. Now, there are other two forms of data you may want to consider collecting as well. Things like logs, because logs will contain textual data about failures and problem areas, things that cannot be expressed in the metric. But there's also traces, and traces are more about message flows, meaning how do messages move from point to point, from, let's just take from on-prem environment over gateways, and let's just end up in the Azure SB. How are you going to track these transactions of these payments across the whole range of these hops? And what I call it a cross-mesh context propagation. Not only you want to be able to see where the messages are, but you also may want to connect them together. And what I mean by that is say, well, the order goes from, let's just say from Solace to a gateway and then gets split. Well, you need to be able to then, to be able to observe that split. So the context propagation across the whole mesh becomes an important consideration. So think of it as logs, traces, and metrics being aggregated and then being sent into the observability platform where that can all be analyzed. And then you can do things like analytics, reporting, and alerts so that you can now say, hey, here's where my messages are, here's where the latency is across the whole environment. Now, it does require potentially organizational augmentations, meaning instead of coming from the siloed approach, you need to be able to kind of look at it as a holistic one system. So it's not just the tooling, it's also going to be processes and people and how you organize. But the idea is that to go away from I would say the siloed kind of concept into the one platform concept, and not just focus on the metrics, but things like logs and traces. So moving forward, just what is it actually going to look like? So this is just, again, a diagram of what it may potentially look like. Now, in this case, imagine you have multiple things happening, whether that's Azure SB or other on-prem. The idea is to connect all of these dots together and look at it as a flow, as a single flow. Whether that happens in the cloud or whether that happens in Kafka or that happens in Azure SB, the idea is to be able to connect almost like a train track and say, where are the messages flowing? Can we look at the volume? Let's see where the volumes are. Do we have any lags from the producers and consumer standpoint? Is there any latency? Are there any problems, errors? And this really combines all of those concepts of metrics, logs, and transactions all being put in one place. And you should be able to really look at one picture to see the whole flow. Now, if you don't have this, essentially, each of these applications, you're going to have a set of visualizations and a set of visualizations here. And then you're going to have to connect those dots somewhere on a call with a bunch of people together trying to figure out how all of this stuff actually works together. That's a very challenging and very time-consuming process. Versus being able to look at the flow and say, well, here's what the flow is, here's where the data is, here's what the latency is, and then being able to then react appropriately and get even notified proactively based on the flows. And just in summary, consider when you're doing migrations or augmentation with the Azure SB and your legacy and other messaging platforms. Think of the model. Are you moving completely over, and it's still going to be a process kind of in between, but at some point you're still going to have this hybrid environment, right? Or is it an augmentation where you're just adding on? Obviously, consider skills, tools, and processes, and especially data, where the data is and how it needs to be accessed. And then based on that, are there any specific impact, whether that's from compliance or security standpoint? I would say observability needs to be looked at very early on, because if you do it later, then you end up with a very disjoint kind of siloed approach that introduces a lot of risk. And with the risk, obviously, comes could potentially be significant impact on the business. Consider message tracking in this. I would say it's part of the observability kind of objective is, well, yes, you can look at metrics, you can look at how things are doing, but the question is, do you really know where your messages are? And that's especially valuable for things like high-value messages. People will ask where payments are, orders, and invoices. I would say avoid siloed disjoint observability approach. I know oftentimes it's not possible right away, but at least have a strategy where it gets you to that single platform approach. And also consider diagnostics, because even though you may have an observability platform or have an observability approach and you know where the problems are and be able to track them and figure out what broke, how are you going to actually diagnose these problems and actually fix them? So consider the whole loop. Detect, kind of track, detect, act, and what are you going to do when problems happen and how are you going to actually fix them? And then also consider that within the CI/CD pipelines, meaning how do you automate deployments across this hybrid environment, whether that happens on-prem or in the cloud. And I think with summary, when I conclude this, and then we can jump into the Q&A and see if anybody has any questions.
Yes, so yeah, we will now open up the floor for a live Q&A. So if you have any questions from the presentation, you can now send them in the chat box. So far, we have received a couple, and the first question that came in was, what strategies do you recommend for minimizing latency and optimizing performance when using Azure Service Bus?
Yeah, so I usually look at proximity. So you can move workloads to, let's say, Azure SB. The question then becomes and usually applications always have data that they refer to. And that means databases, warehouses, whether that's customer data, payment data, or other web services. The question that you will always have to look into is, where's the data and how it could be accessed. So you can move the workload to let's say, to Azure SB, but if your data is elsewhere and now you're incurring latency cost on that, well, you've just potentially introduced a dramatic amount of latency, even though the stuff that's happening on the Azure SB is actually very, very fast. So I would consider the whole ecosystem, and when you move workloads, consider things like where the data is and how it's going to be accessed. The other, obviously, is you want to be, depending how Azure itself is deployed, and looking at where your apps are versus how your data centers are deployed in different locations, because you have control over that. And also consider I/O. A lot of messaging is obviously persistent, which means messages are stored and can survive, for recovery. So you would have to consider things like where the message is stored, how fast the storage is. But I think the bigger latency is usually introduced on accessing the data itself. So those are the kinds of, I would say, again, generally, without looking into a specific use case, but those are, I would say, proximity to the data, proximity to the data stores that you have, and how the data centers are configured and distributed, especially in relation to your other legacy platforms. So if you're, for example, if your data centers are, I don't know, let's say in New York, and you're deploying somewhere, your Azure SBs elsewhere, consider the latency that you will incur from your on-premise environment to these data centers.
Great, thank you. The next question is, what considerations should one consider when migrating Java and MQ apps to Azure SB?
So a lot of the Java apps, especially if they're JMS, that could be migrated fairly in a straightforward way, because Azure SB already supports the JMS2 spec. So that probably doesn't even require code changes. Although if you have an MQ application, that may, depending on how your MQ application is actually written, if it's using over direct MQ bindings, then you're probably going to have to rewrite code to do this. But yes, it depends really. Java applications, JMS applications could be moved in a straightforward fashion.
Great. The last question I see is, can you discuss common trade-offs involved in choosing between Azure SB versus Kafka or IBM MQ?
So Azure SB is, I would say, more similar to IBM MQ in the sense of it for high value messaging and transactions. I would say Kafka is more for smaller messages and high volume messaging and event streaming. I think Azure has its own kind of equivalent of that. But so if you want high value transactions, then you would use typically Azure SB and or MQ. And then it really depends on whether you're using, on-prem versus cloud. So if you're in the cloud, if you're migrating cloud, especially Azure, then obviously your choice is Azure SB. I don't see why would anybody pick, for example, I don't know, you're running in Azure, but then you suddenly somehow using MQ. I mean, you could, I guess, but a more natural approach would be, hey, what's your cloud environment? Well, I'm an Azure environment. Well, then your choice is really the Azure messaging, Azure SB. But you can interconnect that with your, let's say, IBM MQ environment that's running on-prem, and that could be interconnected in a fairly easily. So in this case, Azure SB and IBM MQ, I would say, are much more, equivalent in its functionality. And then Kafka, I would say it's a completely different messaging, and it's more for high throughput, high volume, much shorter messages on the pub sub. And the other thing is, topics, like, for example, Azure SB supports both queues and topics versus Kafka is mostly topic-based, a messaging platform. So again, if I'm doing high value or even like large messages and I'm in Azure, I would obviously use Azure SB.
Awesome. Well, if we answered all your questions, we can go ahead and wrap up. Thank you so much, Albert, for your presentation today, and thank you everyone for your participation as well. Later today, we will have this Tech Talk available on demand, posted on the meshIQ website at www.meshiq.com. We would love to see you all again, so please be on the lookout for our future webinars that will be posted on our LinkedIn. Thank you all once again, and have a great rest of your day.